Dans téléchargement de votre repère, créez un répertoire ISI puis créez 3 répertoires direction. Professeur et étudiant dans le répertoire ISI.
En effet, l'entreprise est un ensemble d'acteurs nécessairement différenciés intégrés dans un réseau d'interaction réciproque pour réaliser des objectifs qui ne sont ni communs ni immuables. Cette définition prévoit des variables psychologiques. D'autres définissent l'entreprise comme une organisation qui ferait des crimes rituels, qui est le terme le plus générique et le plus adapté à la gestion, car il englobe la dimension interne de l'entreprise et sa mission externe. La définition proposée par SP Robbins peut être retenue. Une organisation est un ensemble de moyens.
2. Créer dans le répertoire direction car répertoire TG, DE, comptabilité, DEPGL et
which is the container runtime interface, and it will tell I need to run this particular pod. Can you fetch the image? Can you fetch the image from the registry? Can you attach the network? Can you do, there are like CNI, CRI, CSI, 3 components are there. So 3 components which
un mécanisme dont les rouages doivent être huilés où chacun doit
CRI is the runtime interface, which is container. CNI is the networking component in Kubernetes, which is planner. I told you this Kubernetes involves a little step. You need to learn some of the terminologies. That's why I'm going slow over here. Yes, I'm going slow.
Créé dans le répertoire professeur du répertoire permanent et
storage interface. And the implementations include, so those are the interfaces, the standards. Then they have the implementation. The container D is the implementation. Planner is the implementation. Longhorn OpenEBS is the implementation. So then container D will get the image, attach, whatever the IP, the roots and all that stuff will be there. And then Qproxy,
vacataire ensuite créé dans le répertoire étudiant de répertoire classique et bachelier orienté.
The node of another node. How to do that? Qproxy maintains a network rules. These network rules allows network communication to your pods from network sessions inside or outside of the cluster. So it maintains the list of basically IP tables or IPTS. And every time a pod is created, the IP tables is handled by Qproxy, and you can actually check IP tables -L command on the node that. So
okay.
Now.
Un système qui s'adapte à son environnement.
So request came here. Scheduler defined. Kubelet said I want to run like APS I want to run this particular pod. It talks to the CRI and then uses CNI to attach the network and all that stuff. It updated the IP tables and now the pod
et dans le répertoire classique ces fichiers GL, GDA, Télécom, CS, IAG et réseau. Car copie.
So that's actually the deep dive stuff. So now the container is running and yeah, the container is running. Now, the thing is, this is just a simple example. Where does controller manager comes into play? Now, there are different objects in Kubernetes which we'll talk all in this workshop. Now, if I want to run 5 replicas of my application, so I will create a different type of object which is there. And that will be controlled by the controller manager. So controller manager is a kind of binary that is having multiple controller managers, like replica set controller manager, deployment controller manager, job controller manager, stateful set controller manager, daemon set. So these are actually Kubernetes objects. When I go to that section, you'll understand what a Kubernetes object is. So these are set, like this is the pod.
Copier les 3 fichiers GL, IAG et GDA dans le répertoire DEPGL.
Like this, controlling that. Out of those 5 replicas, if your node goes down, 3 replicas went down, then at least those 3 replicas are spin up on another node will be responsible of control manager. Control manager will tell API server, hey, there is a mismatch and I only have 2 replicas ready out of 3, please create another one. Then again scheduler will say, okay, this particular node has it and run it over here. So that's how the process goes on. That's a reconciliation loop. So this is the terminology that you will hear often when you are in the Kubernetes ecosystem, reconciliation loop. So that's the reconciliation loop which is there, and your controller manager is responsible for continuously looping through and checking if your desired state and actual state are same. So in Kubernetes, you define the desired state. I want 5 replicas of my application. I want 5 photocopies of my application. Very layman terms. Controller manager is responsible for running those 5 copies of your application. Now, the last component, which is not, which is kind of not the core component, dependent on the cloud. So it is CCM, Cloud Controller Manager. So whenever I'll cover in the end. So whenever you kind of create a service like load balancer or anything that connects to the cloud, so basically you cannot create a load balancer IP.
Lima, copy the pictures that Telecom Dance was recording.
Cloud is supporting that.
Vous allez pas d'émission de l'entreprise. Alors dans cette partie, on va voir comment on classe ces entreprises et leur nom à partir du nombre d'employés qui sont.
So that was your Kubernetes architecture.
Le
now you know
utilisé est celui du nombre de salariés. En effet, les entreprises n'ayant aucun salarié sont qualifiées de micro-entreprises. Ici, je ne génère pas d'argent, mais je n'ai pas de salariés. C'est un peu moi aussi une micro-entreprise. Ça, c'est un exemple banal. Les entreprises de 1 à 9 salariés sont qualifiées de très petites entreprises. Les entreprises de 10 à 50 sont les petites entreprises de la catégorie de grandes entreprises. Comme par exemple, je ne veux pas prendre Facebook comme exemple, je vais dire YouTube. Voilà, c'est bon. On va être content. Ouais. On va prendre quoi comme exemple? TikTok. Ouais, plus de 500 employés. Twitter, plus de 500 employés. Voilà.
Cool.
Pour prendre un exemple africain, nous avons quoi? Gabon Télécom, plus de 500 employés. Vous comprenez?
Now, again, I told you, it's beginner friendly. It's Kubernetes from scratch.
Dans le langage courant qualifié de PME,
the next important topic is YAML, because this
de
is what
0
you
à
will be actually creating.
499 salariés.
So what exactly
Donc,
is
j'ai une
YAML?
PME entre mes mains. Vous voyez ça? Je pèse moi.
So YAML is a widely
2.
used
Classification selon le statut juridique.
file syntax
Les
in
entreprises
the cloud
privées,
system,
entreprises individuelles,
space. You have human readable data serialization language. So it's a human readable data serialization language.
Attendez, il y a une faute là, je vais la supprimer tout de suite.
YAML and markup language. That is the full form of YAML. YAML and markup language.
6. Ouvrir avec l'éditeur de code Debian le fichier gl.txt et écrivez une phrase puis affichez son contenu dans le terminal.
Happen on the basis of labels. I should know which labels, which ports I actually have to send the traffic. Service will be able to send the traffic based on labels. Deployment, like there are 5 replicas. So I need to know those 5 replicas should have the same label. Else I won't know that they are part of my deployment or not. So in metadata, I have this label. And here I have the match labels. So selecting on the basis of labels. So these spec will be of the containers. Spec will be of the deployment. So you are matching the label. So in the selector, what you do is match labels. So selecting on the basis of labels. Another example. When you are doing selection, now this type of selection is called equity based selection. Also one of the other example is node selector. So you can actually add a node selector and it will be based on the key value based, which will be equity based. There are other advanced selectors which are like set based labels, which have in, not in, exist. This is a bit complicated concept, stay with me. So this is example taken from the docs. So like this, selector, match labels, component redis. This is normal equity based. Now second one is match expression. Then is match expression. Here I am saying key operator in values and then I give the values. Key environment operator not in values. So in, not in. So for very complex operation, I do not think that you will be using it anytime soon, because 90% of the work can be done without this, or you just have to have simple labels. That's it, simple key value pairs. Let's move on to the exercise for this. So create an image, move to the exercise repository. So labels and the selector, run the image in Nginx. I think this image should already be there. No, because we have switched to dev namespace, so we can create that. Anyways, create that. Then create a deployment nginx. I think this is created. Let's label the pod, kubectl label pod. First get the labels, kubectl get pods -- show labels. So you can see the label is there, run nginx. Now label the pod from the next command, kubectl label pod nginx app demo. Now again run the command and app demo is added. So I'm not lying. So this is how you add the label, and this is how you see the labels added to your cluster. So document will only be given to those who stay till the end. Very simple. So just keep learning. So now we know about the labels and selector as well. Cool. I think
on verra comment faire le programme.
Yeah. After this, you can come to the init container section, please, in your file, and leave the above one, because above one is something that we'll do in the end. Come to the init container section. Okay. Cool. Now let's move on with Kubernetes. So till now what we have learned? We have learned Kubernetes, we have learned pods, we have learned we have learned what Kubernetes is, why Kubernetes, we have learned about the architecture, deep dive, we have learned about what namespaces are.
Ouvrir avec un éditeur diffère-iage.txt puis afficher.
All namespaces are, its use cases. Cool, that's a lot of stuff that we have covered. Now let's move to more action. So these are pods. Now in Kubernetes, anything that you run as pods. In Kubernetes, anything that you runs as pods. So everything will be running as a pod. You want to run a container, but it will be running actually as a pod. So you have your so this is how it will look like. So this is the pod manifest that we have seen a couple of times now, and you should be aware of it now. So this is the pod. Now how it runs on a particular node. So your node is nothing but a virtual machine or a bare metal machine or Raspberry Pi, whatever it is there. And each pod will be running a container.
Son en-tête et ensuite ouvrir encore avec un autre éditeur diffère et afficher avec une autre méthode.
So there is a pod IP range. Every pod will be getting its own IP. So each pod will be having its own IP. In this particular section, in the metadata section, this is the pod name and this section is the container. So this is the pod. Now what all things we can do with the pods? Let's see that. Clear the screen. -- image equal to IM is created. kubectl get. So these are the operations that I'm trying to show you. So after creating, you can get the pod. How to get the pod? kubectl get pod. This is the first command that you should be running. Like describe it. What is happening with your pod? So first the scheduler scheduled this to this node. Then the image started pulling, like kubelet gave the action of pulling the image, then kubelet gave the action to start the creator, then it started the container. So it tells you
écrire dans le fichier solde sans éditeur de code puis afficher son contenu.
It also tells you that which is its best effort. I will not tell you about the quality of service class because it has out of the scope of Kubernetes 101. Then you have mounts. What all mounts are there? So this mount is a service account token with which you can actually interact with the Kubernetes API server from within the pod using this token, which is mounted inside every container. Then it gives Calico project. So Calico is just another CNI, and that's the functionality of it, that it is adding the annotation. So you don't have to worry about it. You don't have to take care about that. So you should be describing, and then it also gives the name of the pod, namespace, and the node where it is actually running, and the labels as well. So it gives the complete description of the pods. the next step is there that whenever you create the application, you see the logs of your application, right? So similarly, you can see kubectl logs -f is to follow of the pod. So I can just see the logs of my pod as well. So whenever any new request will be there, there will be logs for this. So this is how you see the logs of the container. But other action you can perform is kubectl get pods. I can delete a pod. So kubectl delete and go to different directory user
10 official le repertoire de bacheliers orients,
and then you can exit the pod. Then kubectl get pods. Last thing, yeah, you can do kubectl get pods -o wide. This actually gives you the WID. So this gives you the wider view, not only the age, so it adds more information, IP, node name, and the other stuff which is there. So nominated, etc. So you have the readiness gates, all this stuff. So it gives you extra information about your pod. And one last thing that you can do with pod is actually you can do it with any of the sources is kubectl delete pod siam -force. What happens is whenever you delete a pod, there is a termination grace period of a particular resource. So that termination grace period, I think, is about 30 seconds. So if, for example, just a common scenario, right? Try to open up your mind. Whenever a request is coming, whenever you are hitting a request and you suddenly put a delete command, you at least want that request to be processed and no other further request should be there. So that particular termination grace period, if it is serving a request, then it will be served for 30 seconds and then it will be deleted. Things like that. So that is what is pod is. So you have